Today we're looking at the Special Right Triangles Notes page. And for our generic 45, 45, 90 degree triangle, the sides opposite those angles are reflected by the lengths of x, x, and x times the square root of 2. So if you fill in the information on the generic triangle, the 90 degree angle, where the right angle symbol is, each of your acute angles are 45 degrees. The sides opposite those 45 degrees have lengths of x. Each of the legs are the same. These are isosceles right triangles. And the length of the hypotenuse across from the 90 degree angle will be that number x times the square root of 2. When we actually start using this information to fill in some problems, we can look at the second example on the page, where I've got a leg length of 2 feet, and so I know that the other leg length has to also be 2 feet. I can fill that information in my chart for my actual length of 2 feet and 2 feet. I need to figure out what the hypotenuse length is, and I know because this is a 45, 45, 90 degree triangle, the length of the hypotenuse will be the 2 times the square root of 2. But because I want an actual length, I'm going to go ahead and put that number in my calculator and calculate that. Because if I were using a measuring device, I can't measure 2 square root 2 very easily. So in my calculator, I type 2 square root 2, and that decimal approximation is about 2.8 feet. I can fill that in on both the diagram and in my chart. The third problem on the page, again, is giving me a 45, 45, 90 degree triangle. Notice that in this case, I have the length of the hypotenuse of 1.3 miles. I know that that hypotenuse corresponds to the length x square root 2, and I'm looking for the lengths of each leg. So as I set up that problem, I'm going to say that 1.3 equals x times the square root of 2, and I need to divide each side of my equation by the square root of 2. Since I'm looking for an actual decimal approximation for my miles, I don't need to rationalize my denominator. I just need to put this number, 1.3 divided by the square root of 2, into my calculator. (1.3) divided by the square root of 2 gives me an approximate answer of 0.92. So I know that my actual length involved is 0.92 miles. And I can add that information to both my chart and to my diagram. On the back side of my notes page, I'm looking at my generic 30, 60, 90 degree triangle and the side lengths opposite those angles. So as I fill in my diagram, my 90 degree angle near the right angle symbol, my smaller of the two acute angles 30 degrees, and the larger of the two acute angles 60 degrees. The short side opposite the 30 degree angle is given a length of x. That longer leg, or the medium side, is the one that's the squirrely one with a square root in it, has the length of x square root 3. And my hypotenuse is always twice the length of my short side, so my hypotenuse has a length of 2 times x. When I use this information to solve problems, I'm given the information that the hypotenuse of my 30, 60, 90 degree triangle is 4 feet. I can put that into my chart. I know that the short side has to be half as much, or 2 feet. And I know that that medium side, or the longer leg, is the short side 2 times the square root of 3. Since I'm looking for some actual lengths, I want to go ahead and put that in my calculator to get a decimal approximation. 2 times the square root of 3 gives me a decimal approximation of about 3.46 feet. And I can add that 3.46 feet to both my table and my diagram. If I look at the last problem, notice that I have a 30, 60, 90 degree triangle, and this time I'm given the longer leg, that medium side, of 9 yards. So that information goes in my chart. I need to figure out what the shortest side is before I can figure out the longest side. So just like before, I'm going to set that 9 yards equal to x square root 3. I need to divide each side of my equation by the square root of 3 to figure out that value for x. I want to go ahead and rationalize that denominator. If I have 9 divided by the square root of 3, I need to multiply by square root 3 over square root 3 to eliminate that radical sign in my denominator. When I multiply my numerator, 9 square root 3, when I multiply square root 3 times square root 3 for my denominator, I get the whole number 3. And the number 9 over 3 does reduce. So 9/3 square root 3 actually becomes 3 square root 3. So I know the shortest side of this triangle is 3 square root 3 yards. And the hypotenuse is twice as long. 2 times 3 square root 3, which gives me 6 square root 3 yards long. Because I'm looking for an actual yard measure that I can fill in my table and that I could measure if I were trying to measure this with a measuring device, I want to go ahead and put 3 square root 3 in my calculator. And I get the decimal approximation of about 5.2 yards. So I'm going to add the 5.2 yards to my diagram and to my table. I know my hypotenuse is twice as long as 5.2, and 2 times 5.2 gives me 10.4 yards. I'm going to add that to my diagram and to my table.